Newton's second law of motion. According to the Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the applied force and take place in the direction in which force acts. We know that change in momentum is equal to mv minus mu. As we already discussed in the previous class, momentum is equal to mass into velocity. If we have to calculate the momentum of any body, then we have to multiply its mass and velocity. So now here we have to calculate the change in momentum, then we have to subtract the initial momentum from the final momentum. According to the Newton's second law of motion, force applied on a body is directly proportional to the change in momentum upon time taken. Force is directly proportional to m in v minus mu upon t. If we take m as a common, then we get m v minus u upon t. We know that v minus u upon t is equal to acceleration. Then we get force is equal to m into a. It means that force act on a body is directly proportional to the mass and acceleration of a body. If we simplify it and we can rewrite it like this: a is equal to f upon m. It means that acceleration of a body of any object is directly proportional to the mass, directly proportional to the force, and inversely proportional to the mass of an object. I am repeating it again. It means that the acceleration of a body is directly proportional to the force and inversely proportional to the mass of a body. Directly proportional means if we increase the acceleration of the body, then the force of a body will also increase. Or you have to apply more force if you have to increase the acceleration of the body. Similarly, if you have to increase the acceleration of the body, then you have to reduce the mass at constant force. Inversely proportional means if you are increasing anything, then you have the another thing will decrease. And directly proportional, both things are increasing or both things will decrease together. And we know that the SI unit of force is Newton, and 1 Newton is equal to 1 kg of mass of a body have 1 meter per second square acceleration. And we already seen the application of Newton's second law of motion at so many places. Suppose you already seen a player who, while catching a ball, he moved the hand in backward direction. Suppose he catch a ball, then he moved the hand in backward direction. Why he moved the hand in backward direction? Here, when the ball is coming at the high speed, the initial momentum of the ball is too much, and when we catch it suddenly, then the momentum will be reduced because its velocity will be 0. Then here the time taken to change the momentum to 0 is very less. To increase this time, the player move the hand in backward direction. In this way, the time taken is increased and player did not get hurt or did not get any injury. Similarly, you seen the athlete while taking the high jump, they do jump on a cushion or heap of sand. Here this is also because when he jump from the higher place and fall down on the cushion, then in this way the time taken to change the momentum to 0 is increased. Similarly, as you already seen and you observe We use seat belts in cars. Similarly, here the time taken to change the momentum will increase.